Hello everyone, this is Mohammad Parsazadeh. The project title that I am working on is Predictive Modeling of the Abrasive Performance of Overlays and Coatings. And the project contributors are Dr. Shao, Salman Sayalatifi, Dr. Hogan, and Dr. McDonald. In ASI project, the group seeks to develop long-lasting materials with better performance using autonomous manufacturing and repair processes. To reach this goal, we are focused on analyzing how materials fail and what mechanisms are involved during failure. As you know, studying processing structure properties will help reach a better performance. One of our group members, Dr. Shao, is mainly taking care of the experimental part of the project and focused on the design of high-performance coatings. He has also published his findings on the journals listed below. He is focused on microstructure-based design of aluminum matrix composite and studying the damage mechanisms via tailoring matrix and particle size, shape, and deposition rate. As you can see in this slide, his research is split in 4 categories, namely design and fabrication, which is the processing and preparation of the samples, studying the microstructure and evaluating the mechanical properties of the samples, and the damage analysis under compression loading. Following Dr. Shaw's research, another member in our group, is trying to develop physics-based multi-cycle models to numerically evaluate the failure mechanisms and predict material performance. Salmon research can also be described in 4 steps. The experimental data obtained by Dr. Shaw is employed to generate RVs, then proper constitutive and damage models are employed for the matrix, particles, and the interfaces. The results are then validated with the experimental data and a predictive model is generated. I am also working on numerically evaluating the abrasive resistance of metal matrix composite coatings and developing a model to predict the material scratch resistance. I am working on 2 objectives. First, I study the effects of microstructure on the scratch resistance of tungsten carbon nickel composite coating under single scratch load. And in the second objective, I'll have subcritical cyclic loading. These are the steps that I have to go through in the methodology. The schematic diagram of the indenter and composite is shown here. Johnson-Cook material and damage models are employed for the matrix, and Johnson-Holmquist model is used for the particles. These equations are shown here in step 2. The equations are discretized by means of finite element method, and the results are validated with experimental data, and the accuracy of the model is evaluated. The material displacement contours in top and side view are shown here, and the worn volume versus volume fraction of the particles is shown here. These results help understand what materials removal mechanisms are involved during the scratch test and let us predict the worn volume. The model generated can be integrated into a robot, and the robot can do the autonomous repair. The complete analysis of these results has been published in Ver Journal. In my second objective, I am simulating the scratch test under subcritical cyclic loading and evaluating the material removal mechanisms at each cycle. These were the wear rate is shown after each cycle, and the wear mechanisms causing material removal is analyzed after each cycle. The results of this study is getting ready to be submitted on Tribology International Journal. These are our collaborators, and thank you very much for listening to my presentation.